Here is a setup that we're going to see over the next few videos. We have an average number of calories in a 1.5 ounce chocolate bar of being 210 calories. Now, suppose that the distribution of calories is approximately normal with the standard deviation of 10 calories. Now, surprisingly, when you go to the grocery store and you pick up a chocolate bar or a box of cereal, or a can of soup, it doesn't matter, and you read the label and it says calories is 210 calories, that, believe it or not, is not exact. That is a mean value, and there is a standard deviation, and we're talking normal distributions. And um, this is how the food industry works. They take a sample of their food items and they get a normal distribution of whatever food item there is, and they take a food item, they take the average number of calories or the average grams of sugars or whatever, and that it's that average value that they report on their nutrition label. So this is a good example of what those nutrition labels are actually reporting. So let me read that again. The average number of calories in a 1.5 ounce chocolate bar is reported to be 210 calories. Suppose that the distribution of calories in this reported nutrition label is approximately normal with a standard deviation of 10 calories. So any particular, if you just randomly choose these chocolate bars and you measure the number of calories in these chocolate bars, then you'll be able to map out the calories in these chocolate bars, and you'll see that they form approximately a normal distribution with an average of 210 and a mean or standard deviation, of 10 calories. Cool. All right, so this is the setup we're going to be seeing over the next few videos. Here is the first problem we are going to deal with. Find the probability that a randomly selected chocolate bar will have less than 200 calories. Now you'll see on the bottom left-hand corner of your screen a graph with the left-hand side of the graph shaded in red. And that shaded area is less than 200. That's the area that we have in question. And notice the question is, what's the probability that the number of calories is less than 200? So we shaded the area less than 200. Again, I'm going to emphasize this one more time. Area is equal to probability. So we shaded the area less than 200. That means we want the probability less than 200. All right, so let's pursue this. Now, if you have a TI-84, there is a way that you can just plug in average is 210, standard deviation is 10, my value is 200. It will calculate the z-score for you, and it'll calculate the probability for you. It'll just do it all for you. I'm going to do the long way so that you can see the full process of what is going on. Also, for those of you who don't have a TI-84, so that you know what to do. All right, so the first thing we need to do is we need to find the z-score. Now, remember the equation for the z-score is we take our value, 200, minus the mean, which is 210, and divide by the standard deviation, which is 10. Well, that gives us a difference of negative 10 divided by our standard deviation of 10. That means minus 1. Well, wait, now that actually makes sense, right? Because our value of 200 is 10 below the mean. And we have a standard deviation of 10, so we're one standard deviation below the mean. So it makes sense that we have a z-score of negative 1 because we're one standard deviation below the mean. Hey, it works. Okay. So now what we need to do is we need to look on a z-table and find what's the probability of getting a z-score less than -1. In other words, we need to find that area less than -1. So let's pull up a z-table and let's find that area less than -1. So we find on the left-hand column -1, and then find the column -1.00, and that will give me this value right here of 0.1587. And so we get that the probability of a z-score less than -1 is 0.1587, or 15.87%. And there's the answer to the question. If we have 1.5-ounce chocolate bars having an average calorie count of 210 calories with a standard deviation of 10 calories, the probability of randomly selecting a chocolate bar that has fewer than 210 calories is only 15.87%. So there you go. There's our first example. When we come back, we'll have another chocolate example, but this time we're going to talk about probabilities greater than a certain value.